Figure 4 shows a submarine being propelled forwards underwater. The thrust and the resistive forces are represented in magnitude and direction by the arrows in Figure 7. Which one of the following is correct? My forwards thrust is much greater than the resistive forces, so the submarine is speeding up. If it was slowing down, the thrust would be smaller than the resistive forces. Constant speed, the arrows would be equal, and then also would be constant velocity. The propeller forces water away from the back of the submarine. Explain why this produces a thrust in the forward direction. So this is because of Newton's third law, which is every action or every force has an equal and opposite reaction force. So that gets me my first mark. The second mark here, I need to say what those forces are. So the water is pushed back by the propeller or by the submarine. So the submarine is pushed forwards by the water. We've got equal and opposite forces happening in the opposite directions. So water is pushed backwards, the submarine is pushed forwards, and those forces will be the same size. For a submarine to come to a standstill, its engines are put in reverse. The propeller then runs in a reverse direction, producing a force causing the submarine to decelerate. It takes many minutes to come to rest. So that's a hint there to talk about time. Explain using Newton's second law why it takes many minutes for the submarine to slow down and come to a standstill. So again, 2 marks. So Newton's second law, you might remember as F equals ma. Well, that hasn't got time in there, so we need to expand on that a. So that equals mv minus mu all over t, as acceleration is v minus u over t. This you may have used in P2, where you talk about the force on a car in a collision. So that's the change in momentum over time. So this there, we can say for our second mark, is the reason a long time is needed is because of the large change in momentum. Suggest 2 advantages of using nuclear-powered submarines compared to diesel-powered submarines. So there are lots of different things here you can say. Number 1, I'm going to say that nuclear doesn't contribute to global warming. There is no carbon dioxide released with nuclear. Also, I can say occupies less space. So this is because it lasts longer. And also because it lasts longer, there is less reason to resurface. So you can get the mark for nuclear doesn't contribute to global warming. You'll get a mark for no carbon dioxide released, a mark for occupies less space, a mark for less reason to resurface, a mark for lasts longer, and the final mark would be does not involve a supply of air. Part C, the submarine is stationary. The engines are put on maximum power and the submarine moves forward. The engines maintain maximum power. The forces resisting the movement of the submarine increase as its speed increases. The submarine remains horizontal. Explain how the forces acting on the submarine affect its acceleration up to and after it reaches its maximum possible speed. The fact they've told you the submarine remains horizontal, I'm not going to talk about the up and down direction forces, as they are not going to change as it remains horizontal. So the forces I'm going to discuss are the forwards thrust and the reverse, the resistive forces. So they say the submerged submarine is stationary, so start with that. The submarine moves forwards, so what must have happened there is the maximum force is applied with 0 resistive forces. So at the very start, we get the maximum force applied with 0 resistive forces, so this means maximum acceleration. So as speed increases, the resistive forces increase. So this is something they said to us here in the question. So this causes a decreasing acceleration. Now it still is speeding up, but just at a slower rate. It's not decelerating, it's a decreasing acceleration. So it is speeding up, but at a slower rate. So I'm going to say that. So velocity increases at a slower rate. Just to explain my sentence there for decreasing acceleration. So finally, we know it's going to reach its maximal possible speed. So where this happens, maximum possible speed is reached when the thrust, the forwards force, equals the resistive forces. Resistive forces such as the drag. So there is no resultant force. So the speed remains constant. There is no longer any acceleration.